Hello everyone, today we are solving the numerical problem based on Smith chart. These are the things you are supposed to find. So firstly what we will do is, we will divide the load impedance by characteristic impedance. Okay, so the load impedance I had was 5 plus j 25 ohm. I'll be dividing it by 50. So I'm getting the value as 0.1 plus j 0.5. Now what I have to do, I have to mark this on my Smith chart. Okay, first you are checking the horizontal line for 0.1 real value, and then upper half of the Smith chart for positive reactance. You see, so 0.1 is mapped, and then 0.5, the intersection will be mapped as ZL. So now you have marked the load impedance. Your next job is to write a straight line from the center of Smith chart, that is nothing but in the horizontal line you see it as 1. Okay, then you are supposed to find input impedance. You are at the load side, so in order to obtain input impedance you have to move towards the generator, and the value we got it was 0.074, and the transmission line is of 0.1 lambda. Add that, so you will get it around 0.174 lambda. Mark that on the outer circle. Once it is done, you are supposed to write the VSWR circle. How do you do that? Keep the center as a reference and then ZL as your radius. Draw a circle. The point at which the circle intersects with the second line, which you have drawn for 0.1 lambda transmission line, that point will give you input impedance. Okay, that's a normalized value. So what you have to do, first get the real value and the imaginary value. Always remember, upper half of Smith chart gives you positive reactance and lower half of Smith chart gives you negative. Okay, so first get the value. So it is somewhere between 1.85. that will be your imaginary value, and at the resistance side, the horizontal axis, you got 0.38. so value will be 0.38 plus j 1.85, multiply it with z0 to get the exact input impedance. That will be 19 plus 92.5 g ohms. Okay, you have found input impedance. What you have to find next? VSWR. See where the circle intersects on the horizontal line. You can find the value as 13. Please do that and verify the value. It might be 13, 13.5. You have to be careful. Okay, next I have to find the reflection coefficient. How do I do that? Again, I'll go with the horizontal axis where the circle has intersected. From that point, I'll write a straight line to the measurement scale. In the measurement scale, you see, you can read SWR, return loss, reflection coefficient. So there I mark the reflection coefficient. In the same way, right side you can measure transmission coefficient and all. But reflection coefficient is having a phase angle as well. So once I get the amplitude, phase angle can be measured in degrees. The degrees are measured from the right side of Smith chart. So please note down the value. It is coming around 126.5. Okay. Same way, at the input impedance, you are supposed to find the reflection coefficient. Amplitude remains the same, only angle changes. Okay. Next, I have to find the distance from the load to V minimum or V max. First, I'll note down right side is V max I minimum, left side V minimum I max. Just find the distance initial to the V minima. I have 0.074, and remember the whole Smith chart is of 0.5 lambda. Okay, so the upper half will be 0.25 lambda. If I want to measure the distance, I can just subtract.